It is generally not permitted to directly connect a 480 delta utility supply with a 480/277 volts Y generator output within legally required or optional standby systems according to the National Electrical Code. The governing code articles found in NFPA 70, the National Electrical Code, specifically the 2005 edition, provide guidance on the installation and operation of legally required and optional standby systems. Firstly, NEC Section 701.7 Code addresses legally required standby systems, stipulating that these systems must be installed and connected to ensure automatic operation. This means that the transfer from the normal power supply to the standby generator and the subsequent restoration of the normal supply must occur automatically without manual intervention. Secondly, NEC Section 701.7 further refines the requirements for legally required standby systems by focusing on the sizing of the generator set. This section mandates that the generator set must be adequately sized to supply only the essential electrical loads during the period required to complete the intended function. This implies that the generator should not be oversized, but rather optimized to meet the specific needs of the essential loads. Thirdly, NEC Section 701.10 Bone addresses optional standby systems. This section emphasizes the independence of optional standby systems from the normal power source. These systems must be connected in a manner that prevents them from being dependent on the normal source of supply. Moreover, the section states that there must be no objectionable interaction between the two sources when the optional standby system is operating. This is a critical requirement that aims to ensure the stability and integrity of both the normal and standby power systems. Fourthly, NEC Section 701.10b2 further elaborates on the sizing of optional standby systems. This section requires that optional standby systems be sized to supply selected load or functions for a period of time sufficient for the intended function of the system. Similar to the requirements for legally required standby systems, this section emphasizes the importance of appropriately sizing the generator to meet the specific needs of the intended application. Fifthly, NEC Section 702.11 addresses the paralleling of power sources. This section states that there must be a suitable means for paralleling the emergency source with the normal source. This is to permit the energizing of isolated portions of the system without causing objectionable interaction between the two sources. This requirement is particularly relevant when considering the connection of a 480 delta utility supply with a 480/277 volts Y generator output, as the dissimilar voltages involved in this scenario can make it difficult to satisfy this requirement. The issue arises from the fundamental differences between a 480 delta system and a 480/277 volts Y system. A 480 delta system is a three-phase system in which the voltage between any two phases is 480 volts. In contrast, a 480/277 volts Y system is a three-phase, four-wire system in which the voltage between any two phases is 480 volts, and the voltage between any phase and the neutral conductor is 277 volts. The presence of the neutral conductor in the Y system provides a path for single-phase loads to be connected at 277 volts. The dissimilar voltages present a challenge when attempting to parallel these two systems. Paralleling requires that the voltages of the two sources be closely matched to prevent circulating currents from flowing between them. In this scenario, the 277 volts voltage in the Y system is not compatible with the 480 delta system, making direct paralleling impractical. Attempting to directly parallel these systems would likely result in damage to equipment or instability in the power system. This is primarily due to the potential for circulating currents caused by the voltage differences between the two systems. Circulating currents can overload conductors, transformers, and other equipment, leading to overheating and potential failure. Furthermore, the interaction between the two sources could cause voltage fluctuations and other power quality issues, which could disrupt the operation of sensitive electronic equipment. To overcome this issue, a transformer would typically be required to convert the 480/277 volts Y generator output to 480 delta. This transformer would provide the necessary voltage transformation to allow for paralleling without the risk of circulating currents or other power quality issues. The transformer must be properly sized to handle the full load of the generator. Also, it should be designed to minimize voltage distortion and other power quality problems. In addition to the voltage and compatibility, the grounding configurations of the two systems must also be carefully considered. A 480 delta system is often ungrounded or impedance grounded, while a 480/277 volts Y system is typically solidly grounded. Connecting these two systems without proper grounding coordination can create ground loops and other issues that can compromise the safety and reliability of the power system. It's important to consult with a qualified electrical engineer to ensure that the grounding configurations are properly coordinated. This will help to prevent ground faults and other electrical hazards. Furthermore, the transfer switch used to switch between the utility and generator power sources must be carefully selected and configured to prevent objectionable interaction between the two sources. The transfer switch should be designed to prevent the utility and generator from being connected at the same time. This will help to prevent circulating currents and other power quality issues. The transfer switch should also be equipped with appropriate protective devices, such as circuit breakers and fuses. These protective devices will help to protect the equipment from overloads and short circuits. Furthermore, the transfer switch must be properly rated for the voltage and current levels of the system. In summary, directly connecting a 480 delta utility supply with a 480/277 volts Y generator output is generally not permitted due to the voltage incompatibility and potential for objectionable interaction between the two sources. Code Article 701.7 Colon, 701.7 C2, 701.10 Bone, 701.10 B2, and 702.11 govern legally required and optional standby systems, emphasizing the importance of automatic operation, proper sizing, and independence of the standby system from the normal power source. Dissimilar voltages prevent paralleling without a suitable means of voltage transformation and grounding coordination. Therefore, it is essential to consult with a qualified electrical engineer to determine the appropriate solution for a specific application. This is to ensure compliance with all applicable codes and standards, as well as to ensure the safety and reliability of the power system. The selection and installation of electrical equipment must also consider the specific requirements of the application, such as the type of loads being served, the operating environment, and the desired level of redundancy. In addition to the National Electrical Code, other applicable codes and standards may also need to be considered, such as those published by the Institute of Electrical and Electronics Engineers IEE and the National Fire Protection Association NFPA. The specific requirements for standby power systems can vary depending on the application. For example, hospitals and other healthcare facilities have more stringent requirements for standby power systems than commercial buildings. It is also important to consider the maintenance requirements of standby power systems. Regular maintenance is essential to ensure that the system is operating properly and is ready to provide power when needed. Maintenance tasks may include inspecting and testing the generator, transfer switch, and other components of the system. It is recommended to establish a preventive maintenance program to ensure that the system is properly maintained. This program should include regular inspections, testing, and maintenance of all components of the system. In conclusion, the compatibility of a 480 delta utility supply with a 480/277 volts Y generator output requires careful consideration of voltage compatibility, grounding configurations, and applicable codes and standards. Consulting with a qualified electrical engineer is essential to ensure a safe and reliable installation. This will ensure compliance with all applicable codes and standards, as well as to ensure the safety and reliability of the power system. The specific requirements for standby power systems can vary depending on the application. It is important to consider all of these factors when designing and installing a standby power system.